Today's lesson, section 7.4a, we're talking about basic trigonometric equations. So here, example 1, we want to solve the following equations. We want to find all solutions, so that means it's for all reals. So here for 2 sine theta minus 1 equals 0, so these ones a little bit more complicated than the ones we showed in the last video. For this one, now you would solve it as if this is your variable, so sine of theta. So solve for sine of theta, and then we'll go from there. So if I add 1 to both sides, that leaves me with 2 sine of theta equals 1, and then I want to get rid of the 2, so I'll divide both sides by 2. So that leaves me with sine of theta, which is what I want, and that equals 1/2. Okay? So for sine of theta, remember the places in between. First, think about where they are in on the unit circle between 0 and 2 pi. So for 1/2, you have two answers, where you have one for pi over 6, and you also have one for 5 pi over 6. Because sine is positive in the first and the second quadrant, that's where you get a positive 1/2. So then now, because you want to find all solutions, remember that sine and cosine, specifically sine for this one, like you get another answer every 2 pi. So then we want, because of the period, so then we want to add 2 pi times k. Now it doesn't have to be k, it could be whatever variable you want it to be. Just kind of stay away from x and y, but like k is usually used, or n is used sometimes, and so same thing for 5 pi over 6. That happens every 2 pi times k. Now remember, k represents the number of revolutions around the circle in either direction, so then you're able to show every solution that way. Okay. Next one, you have tangent squared theta minus 3 equals 0. So here, same thing, you want to get tangent by itself. So then I want to add both sides by 3. So leaves me with tangent squared theta equals 3. And then to get rid of the square, just like you would if you had x squared, you want to square root both sides. So that leaves you with tangent of theta. Now remember, because I'm the one that put in the square root sign, that means that I have the positive and the negative of that square root. So it's plus or minus square root of 3. Now I need to figure out what ratios are going to give me square root of 3, whether it's positive or negative. Okay, so if I think about my unit circle, so let's just take the first quadrant. Okay, it's not going to be your pi over 4, right? Because that just has square root of 2 over 2, comma square root of 2 over 2. So it's not that. And the only options you have are pi over 6, which is square root of 3 over 2, comma 1/2, and pi over 3, which is 1/2, comma square root of 3 over 2. So let's try one, because remember, if it's not the one you picked, it's going to be the other one that you didn't pick. So let's go with pi over 3 for this. So if I pick pi over 3, that means that it's going to be square root of 3 over 2 divided by 1/2 multiplied by the reciprocal. The 2's cancel out, leaves you with square root of 3. So the third pi's are going to be the radian measurements that are going to give you the ratio of square root of 3. The pi over 6 ones would have gotten you 1 over square root of 3, which is not what we wanted. Okay? So for tangent, your possible answers are going to be pi over 3, and then 2 pi over 3, 4 pi over 3, and 5 pi over 3. It's not going to be 3 pi over 3 or 6 pi over 3, because those are pi and 2 pi, and because of those don't give you the same value, so they're really not thirds. It's the thirds that don't reduce any further. So they're left as a third, as a reduced fraction. So Now these would be the ones for in between 0 and 2 pi, but we want to find all values. Now let's think about this. Tangent, remember its period is pi, so its values reoccur every pi, so that's when you get a coterminal point for those. So think about where these angles are connected. So for tangent is positive, so the positive ratio is positive in the first and the third. Okay, well, we'll think about which ones are in the first and the third. This one's in the first, okay, and then fourth, or 4 pi over 3, is in the third, okay. Then the other ones, 2 pi over 3 is in the second, and 5 pi over 3 is in the fourth, and they are the ones that give you a negative square root of 3, okay. So those ones are tied to each other, and these ones are tied to each other, okay. So that means if I added pi to pi over 3, I would get 4 pi over 3. And same thing if I subtracted pi, I would get pi over 3 from 4 pi over 3. So that means I can condense my answers down to 2 because of the connection there between pi. So for the first one, I always go with the one closest to 0. So, and it doesn't matter which one you pick, you can do whatever you want, okay? So pi over 3, you just need to pick one of them, 4 pi over 3 or pi over 3. And since I'm going every pi because of the period, I'm just going to do plus pi k. And then picking one of the other ones, I go 2 pi over 3 plus pi k. So then that takes care of the 5 pi over 3 as well. And then all the other ones that go into there, okay? So then those would be my answers for tangent. Okay, now letter C is a little bit more difficult. Here you have almost a problem where it's a trinomial. Okay, now think about this. Instead of thinking or looking at it with cosine and cosine in there, cosine squared, cosine, think about it with an x variable instead. So if you had 2, and let's replace cosine with x, you would have 2x squared minus 7x plus 3 equals 0. Okay? There, if you think about what you would do for that problem, you would probably defoil or factor and then try to solve there, because you'd have 2 parentheses that you'd split up and set them both equal 0 and solve. So do the same thing you would for 2x squared minus 7x plus 3 as you would for 2 cosine squared theta minus minus 7 cosine theta plus 3 equals 0. Okay? So let's do that. So I want to find my numbers that I multiply here. So notice that both of them get a cosine of theta, just like both of these ones. Like if you made a parentheses, you get an x, right? One of them's got to be a 2, one of them's got to be a 1 for that one. Now let's figure out where would you put the factors of 3 and 1 so that you could get a negative 7. So you could add up to get negative 7. So here, if I put it in the same one, and there, since it's negative plus, that means they're both going to be minus minus. So then if I put it here and here, let's check. You'd have 2 cosine squared theta on the outside, or the first ones. Then on the outside you'd have negative 2 cosine theta. On the inside you'd have negative 3 cosine theta. Well, putting those together, you get negative 2 minus 3 gives you negative 5. So that doesn't really give you what you want. So let's take those out. Let's switch them around. So if I put 1 there and a 3 here, now let's multiply them out. So the first ones you get cosine squared theta, and then outside you get negative 6 cosine theta. Inside you get negative cosine theta, which together gives you negative 7 cosine theta. And then on the last you get a plus 3, which is what you want. Okay? So I was just using that as a checking. You don't need to write that, but that's kind of the process to make sure that you did it correctly. Okay? So now would be the next step is to set them both equal to 0. Okay? So then here, now you have two equations to solve for, so that means you may have multiple answers. So for this first equation, I'll add 1 to both sides, divide by 2, cosine of theta equals 1/2. On the right one, you get, or you would add 3 to both sides, so you get cosine theta equals 3. So then now, think about your solutions. So where does cosine of theta equal 1/2? Okay, now that would be a positive ratio, so cosine is positive in the first and the fourth. And so you get a 1/2 when cosine, or when theta is pi over 3. Okay, and then also when cosine is 5 pi over 3. Okay, and so then since it's cosine, you're going to be adding a value of 2 pi to get all the solutions. Okay, we're still tacking that on and do it the same for both. Okay, so if you added 2 pi to pi over 3, you would get 7 pi over 3. So you would not match up with 5 pi over 3. So that's why you need to show both. Okay, let's go to the other one. Now, what values for cosine, for the angle for cosine, give you the ratio of 3? Now, there, if you think about that, there are no values on the unit circle that are 3 because for cosine, because it's always in between 1 and -1. So then this would be a no solution. So then your only answers are pi over 3 plus 2 pi k and 5 pi over 3 plus 2 pi k. Alright? Let's do another one. Now here you have other stuff. Now still the thought process is to be able to use factoring. So look at what's common between the two. Okay, you have 5 sine theta cosine theta plus 4 cosine theta. So it looks like they both have a cosine theta involved. So if I factor out a cosine theta, what does that leave me with? So I get 5 sine theta plus 4 equals 0. So now I have two things multiplied to each other that are equal to 0. I can set them both equal to 0. And then solve. Now the first one, cosine theta equals 0, that one's already done. The other one, I need to subtract 4 to both sides. Okay, so then subtract 4, divide by 5, sine of theta equals -4/5. Okay, now where's cosine of equal to 0 for your angle? Now that would be on your whole or half pi, so it looks like it's halves. And I'm using my unit circle knowledge to help me with this, so don't think I'm just randomly coming up with these. So at pi over 2, you get 0 for cosine, and for 3 pi over 2, you also get 2 or 0 for cosine. Now here, if let's say I added, like this one's a unique one, and sometimes this happens. Notice that I would probably add 2 pi k to these, but they're an actual decent value away from each other, so you could actually make this a lot simpler because pi over 2 is only pi away, and so if you added pi every time or subtracted pi every time from these two values, you would get each other and all their subsequent other solutions. Now you certainly could leave it like this as an answer, or if you wanted to leave it as a shorter answer, you could say pi over 2 plus pi k, because the distance between them is the same every time. You couldn't do that for the previous one because pi over 3 and 5 pi over 3 are like on one side of it, it's 2 pi over 3 away from each other. On the other side, it's 4 pi over 3 away from each other. So they're not equal proportions on each side. So you wouldn't be able to simplify it like that. But because you have pi over 2 and 3 pi over 2, from both directions, it's a distance of pi no matter which way you go to each other. So then that means you're always going to get all the solutions just by looking at or compacting them by adding pi k to them. Okay, for sine theta equals -4/5. This one we'll need our calculator for. So I need to insert in sine or inverse sine of -4/5. That gives me -0.93, let's say. Now that one's not in between 0 and 2 pi, so I want to add 2 pi to it, just so I can talk about something in between. Okay, so if I add 2 pi, that gets me 5.3, let's say 6. Okay, and so that would be one solution. We could say plus 2 pi k. Then the other one, now think about where sine is negative again, that's in the third quadrant. So you just got the fourth, okay? So let's find the reference number. So 2 pi minus my 5.36 gets me 0.927 or 0.93 like we had before. Okay, so then now if I add 2 pi to that, or sorry, pi, because I want to get to the third quadrant, that gets me 0.4068, which is the same thing as 0.407, and so that would be my third quadrant answer for the same thing. Okay? So this is the type of answers and solutions you'll get once you get to more complicated ones, but know that all the values are not always going to be on the unit circle when you're solving. Okay? Have fun.